Hello, Tim here again. Tonight, in the spirit of Halloween, pun intended, we have a fix. So, my son loves Halloween, and he's always wanted his very own Halloween animatronic animated decoration. And so, we bought him this from a store called Spirit Halloween. It's little Jack Carver. He's an animatronic. So what happens is when you get up close to him, he raises his pumpkin mask really quick and scares, yells, and laughs at you. We bought this a couple weeks ago. It's 2023, so 2023 season, so it's a new thing out from Spirit Halloween. The problem is it's no longer working. My son's been playing with it constantly, and now it doesn't turn on at all. So we're going to try to fix it. It's pretty expensive. So I, we're going to do some troubleshooting on the box to see if we could figure out what's wrong with it. So the first thing I did was I took the wall plug. It comes with a wall plug like this, and the back of the other side of the cord looks like that. I tested this, and the output, I don't know if we can see it. I don't know if my camera's gonna focus. Come on. Let's see. It's like something shiny, metal. Yes, no. Not. What if we do the microscope camera? Let's see if we can do the microscope camera. I can show you. It's supposed to output. See if I can move the camera a little bit more. I apologize if it locks up again, which it's going to, because my cable is dumb. There we go. 6 volts at 2 amps is the output. DC. When I measure this, I'm going to plug it in real quick. We're going to take the multimeter and put it in DC volts. Oh, the one thing I did not check is if it's center positive or center negative. And it doesn't tell you. We'll assume that it's center positive because most things are. Meaning this shield out here is ground or negative, and the inside is positive. So let's see. Turn on the overhead light. Should help. Let's see what we get. Oh. 6 volts. So we're getting 6.2 volts. So it is working. 6.2 volts. Alright, so that's working. And then here's the box. So we've got all the control wires here. I believe this is for the motors and everything, and then this is for the lights on his head. And then you can see we have the infrared sensor cable that you plug in. You can do an external speaker, the step pad try me that they do in the store, and then the volume control DC 6. Yeah. Oh, there it shows you right there. Yep, center positive. So it shows you on this. Sometimes it shows you on the wall plug. Center positive. Yeah, and there's the on. When we plug it in. This horrible buzzing sound. Yeah. What happens if we plug this back in now? Still 6.3 volts. Okay. So clearly something's wrong with the box. Because it wasn't, when it got home, it wasn't turning on, wasn't doing anything, and normally as soon as you plug it in, the head lights up and scares the heck out of you. We're going to go ahead and open this box up and see if we can find out what's wrong. So it's just 2 screws on either end, it looks like. Probably pull that knob off. Come apart like this. Oh, okay. Oh, we got some wires attached here. So yeah, you can see the speakers right here. And we got this PCB over here. Looks like we got 1, 2, 3 screws that look like it's holding the PCB in. Alright. You know what, I'm gonna desolder these speaker wires real quick. Could get annoying. Okay, so there is a negative and a positive. If you can get a Sharpie and we'll mark one of these. We'll mark the positive wire since they're both blue. We'll mark the positive red. So looks like there's a positive symbol on the speaker down here. So we'll just trace that wire over to here, and it looks like the left wire is positive. So we'll go ahead and just color the end of it red so we know that's positive. Turn on our soldering station and desolder these speaker wires so we can troubleshoot the board. I want to lug this speaker box around if I don't have to. Oop, watch out, don't burn that wire. Just solder pretty quick. There, now we got that big part out and we're left with the board. We can go ahead and do a visual inspection of this board to see if we can find any burnt components. I'm going to move my microscope camera in the way here. Go to microscope camera. Looks like it's not disconnecting. So we'll start off with a good visual inspection. Turn my light down a little bit. Got some reflections here, going crazy. Alright, we're just going to look around the board real quick. That's like water or something there. A little corrosion. Glue. So probably some kind of MOSFET or something, I imagine. Not terribly complicated. This looks like our DCN. This is where I believe our DCN jack is. Nope. That's audio. Sorry, we're on the wrong spot. But that is our audio, and that goes. These traces go around. This looks like the main chip here. It's not marked for convenience. There's no markings on it whatsoever. So yeah, this stuff goes over here. Oof, man, this brightness is crazy. There we go. Apologize if this is out of focus. This is kind of... This, I believe... There we go. Yeah, that's our DCN. Put hot glue around it. So it looks like this might be our positive lead, possibly. So we can do some measuring, or we can break out the thermal camera and see if we see anything. I don't see anything visually right now that sticks out, so we'll have to... Like a diode there, some MOSFET or something. Chip LTK 512 8D. Just a bunch of 0 ohm resistors and everything. This is pretty basic. Bunch of resistors and transistors. Let's do a quick thermal image and see if we find anything that's burning up or something. I like to do this step first because if it's easy and quick, you know, why not get it done? I mean, yeah, I can sit here and measure everything on the board, but if you got a thermal camera, why not use it? We'll fire that up and we'll see if anything sticks out. Looks like we got a couple capacitors on this side. Cap here, the power switch. That's our infrared. It's motion activated. Alright, our thermal camera's on, so let's plug this in and see if we got anything here. If you didn't have a thermal camera, you could touch around on the board and see if you find anything. I'm seeing something already. Wow. Oof, I smell something too. Something smells bad. Got electronic smell. Wow, 350 degrees. Something over there is getting hot. Let's see. I definitely got an electronic smell. You know what? Oh, this diode's smoking right here. Oh, and it's burning up. Let's unplug that. That sucker's on, like, about to catch fire. Wow. Holy moly. Let's see if I can get it back under the microscope. See smoke. Wow. Where was that? Ow. Ooh. Yep. It's that guy right there. Whew, he's hot still. No way. It's this diode right here. M7. This thing's getting to 350 degrees. See if we can catch him smoking. Put some alcohol on him. Whoa, yeah, he's done. He is not happy. Look at that. And he just came off the board. Okie dokie. Oof, this board is super hot right now. Wow, he just desoldered himself off the board. He was getting so hot. Look at that. That's crazy. This little diode desoldered itself from the board. It was so hot. It just fell right off. Don't see any cracks or anything in it. Huh. Can measure him. Wow, this is nuts, man. He is so hot. You saw that on the video. It just like desoldered itself from the board. I'm gonna do diode measurements on him real quick. I'm gonna go to overhead so you can see, or not. Let's see. 0.597, that doesn't seem bad. I'll flip him around. Oops. 598. An open line. Huh. So, is he not bad? Do we have a short on this board somewhere still? Wonder if one of these capacitors is toast. This one right here is interesting. Is it that capacitor right there? What's causing all this problem? Huh. Where's the thermal camera? I'll plug it back in again and see if that little capacitor is hot. It might be this cap right here. This cap right here. Our little diode's getting to 350 degrees. It might not even be his fault. Something else is getting hot here. (102 degrees). This chip right here. That's coming from our 6 volts. Do some measuring. Do some voltage measurements and see. Uh, 6.2 volts. I mean, it couldn't have been that diode, could it? Well, this diode's not bad. It was measuring good. Trying to figure out where this heat's coming from. Not gonna use a metal pointer while this is plugged in. I mean, it's only 6 volts, but still. Yeah, it's supposed to be 6 volts going to that diode, so I'm not sure if that diode... You know what, I think I have more of these diodes sitting around. I'm going to measure. .6. Whoops. 0.6. Well, he just flew into outer space. Come back here. Where are you going, dude? I'm not done with you yet. Why were you getting hot? Board's not getting hot anymore. I mean, that diode is going to this chip right here. Looks like it goes can see the connections. The diode goes here, and this connection goes to this chip. What is that chip? Let's go to microscope cam and see. LTK512AD. I'm gonna look that up really quick. Board's like falling away. Let's see. LTK. LTK 5128D. 5128D. Oh, it's a Class D amplifier. It's a 5-watt amplifier chip. I wonder if that is bad. The differential amplifier. Here's the data sheet. So got a data sheet for it, made by LTK. Oh, it's all in Chinese. Well, I haven't brushed up on my Chinese lately, so I guess the good thing is that chip's pretty regularly available. I happen to have those diodes sitting around, so maybe we'll solder a diode on there. The diode's a 1N4007. Well, it said it's not bad. Yeah, I'm wondering if that amplifier chip is bad. So let's try and I'm gonna try to, oops, go to microscope camera and try to trace, figure out where that power goes from that diode. So 6 volts comes in from here, probably goes through here, goes to, yep, goes underneath this resistor here. So yeah, there's that pin of that diode goes underneath here. There's pin 1, so 1, 2, 3, 4, could be pin 6. Let's see. Wonder if we have a bad amplifier. I don't have that chip, so I'd have to order it. Looks like DigiKey has it, or something similar. Bear with me for a moment while I see if I can find the data sheet. It's a 5-watt mono Class AV Class D operating mode. Yeah, it's an audio amplifier chip. And the frickin' data sheet's in Chinese. Like how, So we got input, mode, bypass, SD, VDD, ground, VOP and VON, so positive and negative. That goes to our speaker. Well, interesting. Okay. So I wonder. So pin 5 and pin 8 are positive and negative to our speaker. That's interesting. So we can do tests. We'll do a continuity test and see if this drives our speaker. Or would it be right at the speaker, or would it have to go through something else? Well, no. It's VOP and VON, so here's our speaker leads that I desoldered. Gosh, this is horrible. I'm not a videographer. So there's our speaker leads right there. It's our positive and negative that I desoldered. What does it seem? Oops. Yep. That's our positive and negative to where our speaker was. I apologize. I'm not an audio expert. Let's see. Pin 5 and pin 8 on that chip. So we're in continuity mode. We're in beep beep mode. Yep. So pin 8's going to the positive, which is what the data sheet's showing me. Yep. And then, so if I go back here and I show you on the chip, right there is pin 8, and that's going to positive, and then this would be pin 5, which should go to the negative. So yeah, this is our amplifier for our sound. Yep, bingo. Yeah, so that's our 5-watt amplifier for our speaker. I'm wondering if since I removed that diode, I wonder if now if the board will turn on, or if the guy will turn on. Let me plug him in real quick. Just give me a minute. Since we removed that part of the circuit, maybe maybe we can get him to power on. How do you turn this on and off? Sorry, I'm just having fun here. So maybe that amplifier chip blew up and the diode was getting hot because it's pulling too much power. Oh, off is in the middle. So we'll turn it off. Alright, I'm going to plug it in real quick to the animatronic and see if he moves. And if he does, I'll put it on video. We're just going to do a little setup here. Just plugging in cords here. Plug in the infrared sensor. Alright, I'm going to turn him on. Oh, he's already on. He's working. How about that? See if he jumps. You'll hear it. Whoa. Yep, he's working. Okay, I'm gonna Watch. This is creepy. Face cam. Yeah. So he's working now. One more time. Wave to the camera, Jack. There's his infrared sensor. Yep. So that's what's wrong. Alright, well. Guess I'm gonna have to do a part 2. Because that audio amplifier chip, I bet, is broken, so, or is blown, so we'll have to order that chip, because I don't have one sitting around. 5-watt amplifier. Ha, that was cool. Yeah, so he's working now. Just that, I believe that audio amplifier is blown, so I know this is probably useless, and this probably isn't going to matter, but I'm going to do some diode tests on that chip and see if any other pins are shorted to ground. Where's a ground point? Or where's something that I can use? Oh wait. What pin is tied to ground? I really got to find a different data sheet. It shows a picture, but it doesn't show what's to ground. There's SD bypass mode in BON, BOP, VDD. Oh, ground pin 7. So we'll put a probe on pin 7, which is ground. Where is that chip at? So pin 7 would be this pin right here. We'll do diode mode. Yeah, so VDD is shorted to ground. No, I don't think it's supposed to be. Yeah. That pin right here is power in. Oh, that's shorted to ground too. What? Let's do resistance. That's annoying. Okay, I'll do black. That way I can just do black probe on. We'll do black probe on ground. Black probe on ground. Zero ohms on pin 8. Yep. So 0 ohms there. 0 ohms on VDD. That's 245K. That's 300K. 300K. 11K. 286K. So VDD, this is power in, is shorted to ground, so that audio amplifier chip is dead. So we're gonna have to get a new one of those and replace it.